Hello everyone. So today our lesson is quadratic inequalities. So we're going to go through and look at how we can solve quadratic inequalities. First is the usual form of a quadratic. This is from your quadratic function. This is the typical quadratic function ax squared plus bx plus c, and we call it inequalities because we have this inequality sign. Now I didn't include, I should include, let's include the other side of it. It could be like that as well, greater than equal to, and the other side is the less than equal to 0 as well. Okay, so these are all called different types of inequality, and the reason they call them inequality is because of the inequality sign. It's not an equation. So this is one form, the general form like that, but sometimes it shows up as a factor form like this. So we have the same setup, but it's written in a factor form, and the truth is that in a factor form is always easier. The reason is easier is because one of the first steps in solving inequalities is that you have to find the x-intercepts. Okay, so that's how you have to go through solving inequalities, and if it shows up in a factor form, it's just easy to do that. If it doesn't, if it shows up in a general form or the x squared plus bx plus c form, then you need to go ahead and use whatever variety of method that you're comfortable with to solve for the x or the x-intercepts. Okay, so that's the first thing. There are two methods of solving. One is algebraic method, the other one is graphic method. So I have this both set up here for you to look at. We're going to start with the algebraic method. An algebraic method is very simple. Once you have an inequality, you must solve for values of x first, but the first thing you got to do, you have to treat the equation or the inequality just like an equation. So this is the crucial part. So let's go through an example and go through it and find out how we can do this. So the first thing is that we're going through, so this is the equation, not an inequality anymore. So first thing is I'm going to change the inequality sign. So this is x squared plus 2x minus 3 greater than 0, but I'm going to solve the equation for the x-intercepts. And in this case, notice that I can quickly use that's a plus 3, the factor form. Okay, so in here we get x negative 3 or x equals to 1. So these are the x-intercepts. Okay, there are two of them. X is equal to negative 3, x equal to 1. But that is the two x-intercepts for the equation. So that's going to start helping us with the solving of the inequality. So now this is the part of the algebraic method that you have to use, and you have to use through the logic of the sign operation. So we are looking at solving basically x plus 3 times x minus 1 greater than 0. That means we want to solve for all values of x such that that inequality is true, x plus 3 times x minus 1 greater than 0. Now be aware that this greater than 0 means is actually, what it means is that it means y, which is the function, has to be positive. That's what it means, because this function, that's actually the y value. Okay, that's the quadratic function. All right, so we want to know for what values of these x this inequality is greater than 0. So algebraically, this is the process. Remember that there are two ways to get a positive value. If you have two numbers that are positive when you multiply to each other, you're going to get a positive value. So that's a positive value there. And you also get a positive value when you multiply two negative numbers. Okay, so two positive numbers will give you positive, and also two negative numbers will give you positive. Okay, so let's go through and set up each one of them. So for the first case, we take both of these brackets positive value. So x plus 3 has to be greater than 0 and x minus 1 has to be greater than 0. So we're going to go through and solve very easily, and that's a solving inequality, linear inequality, and you know how to do that. So the solution for that inequality on top is x greater than negative 3. The solution to the other one is x greater than 1. Okay, now let's put that on a number line. That's the first solution, but let's put it on a number line. Let's suppose this is 1, we got 0 here, and I'm putting it negative 3. I'm just eyeballing it right now. According to this, x greater than negative 3, so that's the first solution on this side, and then x has to be greater than 1. Now, which of the two includes the other one? Which of the two solutions includes the other? Well, x greater than 1 includes every value for x greater than 1 will work for x greater than negative 3. So and if you look at it the other way is that if x is greater than negative 3, so if you choose 0 for here, so if I choose 0 for there, it will not work for there for x greater than 1. So the solution for this part, the case 1, is only x greater than 1, because it includes all the solutions of x minus 3, and that is the first part of the solution. Okay, so now we're going to go and look at the second case. Okay, so now we're going to look at the second case. So x plus 3, x minus 1 is greater than 0, but each of these ones must be less than 0. So this is this part and this part, they're related to each other. Okay, the negative part, that's telling you that is an inequality is less than 0. And when you solve these, what do you get? You get x less than negative 3 and x less than 1. Now remember that this inequality, in order for it to be a positive inequality, each of these brackets must be a negative number when you solve for x. So that's why we get these two. Now let's put them on a number line, and then we have to kind of look at, this is 1, this is 0, this is 3, and negative 3, sorry. And now we're looking at, okay, all the values negative 3 on this side, less than, and we got everything that is less than 1. Now, which of the two includes the other? Well, this one does, right here. Anything that is less than negative 3, it is also less than 1. That means the solution is that for both. Now we need to put them all together. So the final solution, so remember the first solution, we had this one right here, that was the first solution, and then the second solution is this one right there. We're going to put them together. So the total solution, final solution, is we have x has to be greater than 1. So let's go back up, making sure that I'm not copying it incorrectly. Here we go, x greater than 1. Okay, so that's the first one. Let's put it on a number line. Now we have a negative 3, we have a 1, and what based on this, we have the open circle for negative 3, doesn't include it. Remember your inequality diagram, and we are going we're going to the left where every value is negative and is smaller than negative 3, and we're going to go to the positive to the right side of 1, which is all the values that are positive and greater than 1, and these two are the algebraic solution when you work through this inequality. All right, so the algebraic solutions, because there's not just one number, there are many, infinitely many values of x that works for this inequality, applies to this inequality and holds this inequality is true. So if you go back to the original question, which is right here, we just solved for all values of x so that that inequality is greater than 0. All right, so algebraic method is usually more complicated, but the graphic solution is way more easier, and that's what we're going to do next.